Hi, everyone. Thanks for joining us today for our presentation on best practices in load management. And my name is Brad Burwald. I'm product manager at Morningstar, and I know that all of us are spending more time than we like at home and in front of the screen, so we have another great video presentation. We've been trying to create a lot more content and talk about some in-depth usage and features of our controllers, so we hope you find this beneficial. A couple things. I work here at Morningstar in the product management group. So we head up a lot of product development and also work with the applications engineers who are supporting me as well today. Thanks, Doug. And we'll be covering basically how to avoid a load overload and taking a deeper dive specifically into just the load control aspects of our controllers, because there's more to talk about than you may know. The presentation deck is available. If you look at the handout section of GoToWebinar, you'll find that you can download the slides, so feel free to take them. And also, this video presentation is recorded, and you'll find it online on our YouTube channel under Morningstar Corporation, so that you can view it anytime you'd like, on any device you'd like, anywhere you'd like, if you can't get enough of load control. So with that being said, I will also take questions at the end of the presentation. So if you want to go ahead and enter them into the question section in GoToWebinar, we'll be taking those and maybe answering them a little bit via text as well, but we'll also try to take a few audibly at the end as well, so that we can actually support you guys on a variety of answers that you may have if you want to go more in depth. And then, as always, be sure to reach out to us anytime. We've got a variety of channels to reach us, including social as well as email, and we're all here to help you out. Okay, so I will go ahead and get started here. So avoiding load overload, basics to best practices in load management. And what I'd like to do is give a quick agenda here on what we're going to cover. This is going to be an in-depth review in loads and their operation and the variety of which you can actually power in off-grid situations. We're going to talk about why loads disconnect in the first place, and there's a few reasons why, some good, some not so good. The autonomy and loss of load. That's when you do a system sizing, understanding how long you can power your off-grid system for and what determines its reliability. We'll do a bit of a product overview and some features of our controllers that pertain to load management. I'm going to take a few examples of problematic loads that are actually ones that we encounter in application support every day and ways that we have to address them. Some are quite interesting solutions we've seen in our years in off-grid experience with systems. I want to take a special dive into control and monitoring. We've got a lot of new data capabilities, and a lot of our, if not most of our general product line for industrial off-grid solutions is actually enabled for data monitoring and control with a variety of protocols. So I want to go into a little more detail there because there's some newer things to talk about, and also which controllers are supported. And then lastly, I kind of want to, after I review everything, get everything together and talk a little bit about the larger systems that can be built using multiples of our TriStar family. That's the TriStar MPPT and the TriStar PWM, because a lot of our products are kind of an all-in-one design, but as you scale, they get quite large. You can actually use multiple controllers to build larger parallel systems, and that's where you can really provide some significant site management, including cellular and telecommunications is a really big application. And some of those can be 10 to 20 kilowatts in PV capacity. Okay, so a little bit about just an overview in off-grid loads. First of all, they are autonomous. That's why we're providing this remote site power, is they can run on their own. Not all off-grid systems are autonomous. There may be a cabin or something that you're living with and you're actually using every day, and that has a big impact on how the loads are managed. Clearly, they're renewable, so they can regenerate. They're often deployed where the utility can't or won't go. It allows for the best possible placement of your system. So of course, when you're not bound by the utility, you can put your system just about anywhere. And that's why I use an example here of a backbone network for a wireless internet service provider. And that shows that if you want to get to basically the top of the mountain and the best place for your reception, you're going to want to put that tower exactly where you need it, and then you can use solar to power it. Sizing a system properly is key. So of course, there's a lot to that, not just the PV and the battery capacity, but knowing what your load's doing, which we'll talk about today. And then lastly, dealing with load disconnects. It's something that, no system is never gonna run 100% perfect. you should anticipate the fact that they may disconnect, but you can do a lot to actually cause and affect what is going to lead to your load disconnecting or not disconnecting. And that has to do with how well you build your system and, of course, how much you're willing to put into it in terms of cost. So to cover a few basic types of systems, here we have 3 examples of residential, solar lighting, and then a critical application. Okay, and the reason I want to talk about these is the way load control is managed in these is a lot different from each other. Okay, so you can see in a residential system, you know, you're living and using those loads, so you can adapt the load usage. You have a little more power available, you can run more. If you're getting a little low, you can curtail your loads, and you can actually change the way in which you use them to conserve power because you're interacting with the system. And a lot of systems, especially when they're using inverters like a cabin or a small residence, they also will have a generator occasionally that they can use if they need additional power. So loads are not going to disconnect. The customer can kind of manage their power. In a lighting application, the illumination is adjusted available power based on what is in the battery. So you've got a little bit of flexibility. It's not the end of the world if a light turns off. You want to avoid that, but if it's at 5 in the morning, it's probably not critical. So those LVD systems where the load disconnects, they're allowable at times. Also, a lot of more modern lighting loads, clearly LED lights have a lot of capabilities, including dimming, and you're able to actually change the level of illumination based on the amount of power you may have available. Or there might be 2 lights and you can shut off one and leave one on. So you have some options. It's not an all or nothing load disconnect situation. And then in telecommunications, that's just an example, but this could apply to industrial, security, or any kind of critical infrastructure. You've got basically a load that really needs to stay on. You've developed the system, you've put the battery capacity in, and you've sized it in such a way that it's going to run very reliably because it's powering something extremely important and you really don't want it to turn off. There could be lack of communications, unhappy customers, even revenue generation in the case of oil gas that's going unmeasured because equipment is down. So those are actually a very high priority load that you're going to want to take into account. And those also have auxiliary controls such as generators that can be turned on to prevent a load disconnect. And lastly, as I said with lighting, there can be secondary loads that aren't quite as important that can be turned off first, leaving only your most important loads in operation. So when will you disconnect loads? Well, the main purpose of our controllers is, of course, charge control on the charging side and the load side on the load disconnect. Okay, that's the 2 primary functions that the variety of our products enable. And when there's risk of battery damage due to deep discharge, whether it's lead acid that becomes a little more damaged over time if it's too deeply cycled, or in case of lithium batteries, they really can't go below a certain point or else they sustain pretty critical damage pretty quickly if that happens, and they can also disconnect internally. So we're trying to prevent that from happening. So we don't want to shorten battery life. There also may be faults in the system. If there's a short circuit or there's damage to a load, something that's happening with a breaker, then you might shut the loads off because there's a fault or other type of unsafe system condition. And then lastly, when loads are not necessarily essential, there are applications where the load can be ready to turn on, but it's not actually required. If there's a user there, they can choose to use it or not. If the application is not active, like if it goes to sleep, it's only used during part of the day. Obviously, a lighting load is going to turn off during the daytime, and it's not a big deal because it's just not necessary. So those are some of the times when you're going to maybe disconnect the load or choose to disconnect it to better manage the power. Here's a good example of a lighting application. One of the great benefits, again, putting the system where you want to put it. This was actually in the Valley of Fire outside of Las Vegas, referring to one of the elegant establishments that is off the highway on the way into Las Vegas, about 42 miles out. And they were able to actually light up a billboard at night because advertising equals revenue and illumination equals advertising equals revenue. So they want to drive that for, in this case, Clear Channel. Day and night control is typically provided by the charge controller as well as low voltage disconnect. So the controller can provide your lighting sequencing, on off times, dusk till dawn. There's also some options to turn a light on for 6 hours, turn them off 2 hours before, and also on 2 hours before the sun rises. You know, it's the city that never sleeps, so you want to get as much illumination as possible. And again, as I said, if illumination is not a critical application, it can be reduced, but you want to avoid it going off completely. And here's a quick example of our SunSaver battery system. You've got a SunSaver solar charge controller and the lighting control, and then all those timing circuits and everything are built into the controller so that you can manage it automatically, unattended. Okay, so what leads to LVD is, of course, lack of battery power. You don't want to damage the battery, and you're also at that point just you're out of juice. So you have to disconnect the load so that the system doesn't go down completely. So when we talk about how we size a system, days of autonomy is something that we repeatedly discuss with customers, and we provide a lot of OEM and application support for customers that are integrating our controller into another system. And when they do that, they will often ask about, storage capabilities. So days of autonomy is defined as it's the amount of time that a system can actually run off its reserve capacity when you've got little or no solar production available. So, not every day is sunny. There's days of rain, sometimes multiple days. You have shorter days during the winter. How many days can that battery provide autonomy for the load given how you've sized it? Okay, and this is an important factor. You can see 2 to 3 days is a little on the short side, but it's something that you can easily do for something where you've got a user and operator who can manage the loads, and they're not going to want to spend too much on PV and battery capacity because they can kind of get what they want out of the system. 3 to 5 days is more typical for a remote system that requires autonomy. There's no one there to do anything. It needs to sort of run on its own. So it has to be sort of put in place and left alone to run by itself, perhaps months or even years at a time. An occasional downtime, could occur, but hopefully it's sized not to happen. For more critical applications, as much as a week can be provided for days of autonomy. And we've even seen a few, if they're very low draw or need to be very well designed, meaning money invested in the system because it's of a critical nature, you can see up to 2 weeks if something is just absolutely necessary to maintain operation. Some examples over the years that we've seen that I would consider critical applications. We did a railroad system one time for some gate openers and lighting signal operation for the Railroad of India. You've got really remote locations, you've got these railroad crossings, there's safety at stake, vehicles on the track. That's a critical application. You've got to size it right. Luckily, plenty of sun in India to work with. Another application we did was off the coast of Indonesia. As you remember, many years back, a very bad tsunami incident. There's a tsunami warning system put in place. Not a lot of power, just a little bit of communications, but those sensors that would detect those tsunamis coming from the rise and fall of the ocean would actually be solar powered on buoys that were miles off the coast. Definitely a critical application because you've got potentially thousands of lives at stake from that early warning. So anyway, those are good, really critical applications. So one note at the bottom that I wanted to mention to remember is a lot of people often misinterpret days of autonomy as just, I need a bigger battery, but it's got to be a combination of the battery and the PV array sized together. And if you're going to increase one, you've got to increase the other, because merely putting a giant battery in place with not a lot of solar is not going to increase your days of autonomy. It's merely going to give you more capacity, which you probably can't hope to actually recharge reliably. And I've seen a lot of batteries sitting at 30% stated charge, and they can't get full. There's just not enough PV. They're actually too large, and you want to avoid that as well. So days of autonomy, it's a balance of PV and battery. Okay. So an interesting quote I had here that I wanted to bring up. It was from Dimitri Martin. He's a writer for The Daily Show, and he said that batteries are the most dramatic objects. You get other equipment that just stops working or they break, but batteries, they die. They die an awful death, chemical death, never to return. And you've got to prevent that from happening, and that requires proper planning and operation, and ideally quality products as well. So to talk a little bit about the battery, this isn't an in-depth state of charge discussion. I just wanted to kind of refer to the fact that the controller that we provide is known for managing the charging side on the high end and the load disconnect functionality on the low end. So those are sort of the bounds that we work with, and it's there to prevent, or in this case, to aid those two things from operating correctly. Okay, so you can see here, if we look at a really basic graphic to just give an indication of where the capacity is coming from in the battery, you can see that the absorption stage, that's where we do our magic with PWM or MPPT, our 4-stage battery charging algorithm, and all the settings and technology we've put in place. That's where you take good care of the battery and you give it a nice, graceful top off to make sure that it's healthy and not going to become sulfated. The majority of the capacity is in the middle. That's your bulk stage. That's where your battery is going to be cycling. Hopefully not too deep. That's going to add to the longevity of the battery, but that's where your usable capacity comes from. And then of course at the bottom, that's the lower, I would say 10, 20, 30%, depending on how deep you want to take it, remaining state of charge of the battery that you don't want to delve into. You want to avoid that deep discharge. The more often you do that, the more likely the site is to go down, and the more likely you're going to cause long-term damage to the battery. And as I mentioned, in the case of lithium batteries, you know, when they go flatline, they kind of go down for the count. They either shut themselves down, so really they're not meant for you know, going too low, and you got to prevent that. So we've got the active regulation, we've got the time the battery is spending most of the time in, and then we've got that LVD point that we want to protect from you know, from the system hitting. So okay, so that's a bit of an overview on batteries. So to talk a little bit about the load control functionality that's in the controller itself, here's a quick look at our ProStar MPPT. This is with the meter, of course, and a lot of these protections and features that are actually common to all of our products, I want to go into a little detail with. So first, you know, what are some of the protections we provide from faults and wiring errors? This would be your standard short circuit protections, overcurrent protections. These products are there to protect the load in some cases, these features, and to protect the product itself from damage. These are not replacements for properly protected wiring with circuit breakers and fuses that are necessary to prevent wiring and system damage, and in some cases fires or catastrophic short circuits. These protections are there to protect the controller itself. And with the short circuit, when I mentioned it's a current square, that means the higher the current, the quicker the controller reacts. So we can handle little bounces in overcurrent, but if you see a short where you're seeing instantaneous 50, 100 amps on the load side, we know to react really quickly, and we'll take care of that and protect any system damage from that short circuit. If it's just a little bit of an overcurrent, you've just put too much power on too small of a connection, you put 45 amps on a 40 amp controller, you know, we will shut down a little more slowly because it's a heating issue, but that overcurrent protection is there as well. And then of course you've got reverse polarity protection. Now the polarity protection, that's going to occur at the battery. So you got to wire the battery correctly. If you reverse it, the controller won't turn on, no damage will occur. But once it's wired correctly, you got to make sure that you connect your load correctly, because we can't provide a reverse polarity protection for a load. That's something that it has to have itself. Okay. Load high voltage disconnect. Now these are a little more specific types of protections that a lot of people are not aware of, but that's actually an important one, and it protects sensitive loads from spikes in the battery voltage. So if you have multiple charging sources, say you've got a solar controller as well as a you know, a plug-in charger like in an RV or something, and that charger actually brings the voltage higher than the controller is designed to take it, then we're going to disconnect the load in that case to make sure that that load's not seeing high voltages. Okay, that's something that happens electronically very quickly. And we also have something similar, but on the battery charging side, to protect the load as well. And this often comes from industrial applications where they've got a 12 volt DC load. It likes to see 10 to 15 volts. That's the bounds of its operation. And you need to make sure that it's not going to see 15 and a half, 16 volts. Often lead acid batteries, especially in, let's say, northern Canada, where there may be some oil and gas monitoring, is seeing very cold temperatures. The battery may want to get charged above 15 volts. So this max regulation limit will actually put in place a ceiling and not allow that charge voltage to exceed 15 volts. And that's also to protect the load. So all of these protections or features are there to, you know, enable better load operation of what's connected to the controller. Okay, and with this comes a little bit of intelligence as well. We've got some talk about delays and hysteresis, and what I mean by that is when you've got a low voltage disconnect, you know, this isn't just a simple it's on, it's off. You know, we've got to put a little more smarts and intelligence behind this, or else you're going to have problematic disconnects or false disconnects where batteries are bouncing around. So we put a delay in place that makes sure that you've got a low voltage warning period where we're sure that the battery is actually trending towards discharge and load disconnect. And during that warning period, that prevents, if you have a little bounce in the battery, that prevents it from tripping falsely. And then also, once you do have an LVD, unfortunately, you might have to stay in that point of time for a little while because we've got to make sure that we bring the battery back to a healthy level before you turn the load back on, or else you're just going to go right back down again. It's kind of like getting kicked when you're down. You can't turn that load on too quickly after a low voltage disconnect period, or else it's just going to come right back. So we have those timings and delays in place in order to ensure that doesn't get stuck in an oscillation cycle. We also provide current compensation. So when you've got a heavier load, as I mentioned, some of the load capacity of our larger products can be 30, 40, up to 60 amps. And if that's at 48 volts, that's a lot of power, a couple thousand watts maybe. So you've got to make sure that a battery that is heavily loaded, and the battery companies will tell you, you're going to see a little bit of a sag when they can only create that chemical reaction so quick. When you draw that amperage down, your battery voltage is going to dip. And we actually are measuring current on the load side of the controller. And when we do that, we provide compensation so that LVD is lowered along with the amount of current that is drawn, so that there's a bit of an equilibrium, and we maintain that LVD at a lower point because we've got to compensate for those heavy current draws. And that's just something we encounter with a lot of industrial systems that are drawing a lot of current at a high DC rate. Older batteries, you'll tend to see that this kind of sag that occurs on older batteries is actually more pronounced as they get older. They dip lower, they bounce higher when they're under charge. They're not as stiff of a design as they were when they were brand new. Luckily, as the industry transitions in some cases to lithium, if you look at its voltage during discharge, hits a lot stiffer and more rock solid in terms of its resiliency because you've got a much faster chemical reaction, and they can keep the voltage extremely stable even during high current draw, which really makes them a nice application. But if it's sized correctly, regardless of the chemistry, it should do an adequate job. Another feature that we have that has a little more to do with charging, but it's important also for load control, is voltage sense. Now, voltage sense is a little accessory terminal on the side of the controller that we put in place in order to get a better measure of the voltage of the battery. Now, we're reading that through the primary battery terminals that are current carrying, but it's nice to have a secondary reading, and there's a lot of reasons for this. You could have not the greatest wire size. Sometimes you come across a system that wasn't designed as well, and you're seeing more voltage drop than you'd like. The distance between the controller and the battery is also a little further than you'd like to see. And lastly, there could be terminals or disconnect points or circuit breakers in place that are going to also introduce voltage drops. So this voltage sense terminal is something that allows you to go around the current carrying path and get a much clearer reading of the voltage. And it's an easy feature to implement. It's really powerful. The controller handles it automatically, whether it's there or not. And it adds a lot of accuracy for both battery charging and ensuring that your load voltage disconnect is happening when it should. I mean, if you're a doctor, you wouldn't do a sophisticated surgery or work on something technical if you weren't wearing your eyeglasses. So you really want to make sure that your charge controller has the best visibility and clarity of what the true battery voltage is. And voltage sense is a great way to do that. So definitely use it anytime you can. You'll find it on the ProStar line and up on a lot of our larger charge control products. So a lot of these load control features that I talked about, you'll see that if you use our programming software, you can actually set them in a preset for the controller. So if you're deploying a lot of controllers that are all very similar, systems you're doing over and over again, which we see a lot in industrial with many lighting systems or telecommunication access points across a country, you want to be able to replicate those settings. And all these things I just talked about can be built into a preset for the controller, and then you can rapidly deploy them. Also, with the newer versions of the ProStar PWM and PPT, you'll see that presets can be edited as well using the onboard meter display. So any of these functions can be turned on or off as needed, okay, or tweaked in the field, which is extremely helpful, especially if you don't have access to a computer. So another topic I wanted to talk about is the handling of heavy loads. And what I mean by heavy loads is, these aren't LED lights and electronics, Wi-Fi access points. This is big equipment. As we've worked in the oil and gas industry for a couple decades now, we've seen a lot of equipment, and you've seen little monitors, RTUs, PLCs, but we're also seeing injection pumps that actually are, providing, injecting methanol into a well under pressure. We're seeing valve actuators, such as the example given here, where you're actually opening and closing valves that have a fair amount of torque required with a small DC highly geared motor, but there's some current that's required there. We've got some really large radios that are being used. These aren't, Wi-Fi, these are LTE, 4G, 5G access points that are putting out a fair amount of juice. If it's on a macro cell, what you would consider to be a standard cell tower that you're going to see on the highway, hundreds of feet up, these radios are using 1,000, 1,500, 2,000 watts. So that's a lot of power. And then, of course, also inverter products as well. With inverters, they're going to pull a heavy amount of current. Some of these devices may be able to be controlled by the load side of our charge controllers, some may not. And there's some different options that we have to deal with that. So large loads, they present a unique challenge. Of course, they may pull more current than the load side of the charge controller is rated for. So what do? You can wire directly to the battery because the battery can provide that current, but you've lost the capability to actually control it. Inverters, large DC to DC converters, other equipment that has a capacitive or inductive startup surge, things that have to be energized. Inverters are one of them. Big power supplies, they've got caps that need to charge up when they're turned on. Pumps that have they're starting under load, and they're seeing an induced surge that's caused when they're under they're not spinning, they're under full torque. You have to be able to deal with that, and they can't always be controlled by the charge controller. Other devices, they have a bad power factor. LED ballasts, those are not the cleanest of devices, and sometimes they wreak havoc with the solid state controls that we have in place on the load side. Not everything is 100% compatible. So you need to deal with those. Also, some loads, they may need to retain their primary power. In other words, a good example is an inverter. You may want to shut the AC power out of the inverter. You may want to turn that off, but you don't want the whole inverter to go dark, because then you lose data, communications, everything. You just want to disable the output. So it's kind of a mixed mode of load. And those are common also in telecom. Big radio networks, you may want to turn off the radio, but not the back end itself, IT and network equipment as well. So there's a few ways around these issues. So I'm just going to talk, these are just some basic one-line diagrams just for relational aspects of how a system could be designed. So when you've got these heavy loads, you could have a charge controller providing the charging into the battery. But one of the things you can do if the load is too big is you can use a relay, or the load side of the output of the controller also with the relay, and you can do something called soft switching. If the product itself are inverter products, often the SureSign many times has had an example of a remote on-off terminal where we can actually turn the inverter off using a dry contact without cutting power to the DC battery cables. This sort of mixed mode is much more useful and easy to control. The SureSign is done in the same manner. We leave the power, the DC connection to the SureSign, which could be 60, 80 amps at 12 volts, enabled, but we just turn off the AC output of half the circuit by using this soft switching control. So that's a good option. We've done it in solar lighting, heavy industrial equipment, and it's worked very well. And this is where our applications team can really provide some assistance. A secondary option is, of course, enabling a relay in the system as well. So you can put in place a relay control. You can use our relay driver coupled with the load, and that will give you a lot more current carrying capabilities, up to, in some cases, we've seen relays up to 100 amps that can be driven. It enables a lot more power. It gets rid of that surge that's caused by those inductive loads. The only drawbacks are, of course, you lose short circuit capability and you lose the ability to measure the load current being drawn because the controller doesn't have any visibility of that anymore. So, but there are ways around that depending on the system. So these are just a few options: soft switching and relay control that can be enabled. And we see sophisticated groups of these types of products in a lot of our larger industrial systems. So the next thing I wanted to talk about is, understanding what your load really draws and when it draws it, because this also is important for design. I've seen a lot of customers surprised with the equipment they want to power, looking at it from a 24/7 standpoint. It's not consistently drawing the same amount of power. It may draw more when it's doing more computing or processing or transmitting. There could be things that turn on and off within the system that they're not aware of. So you want to look at the intermittent properties of the load. You may want to look at if they have a high surge. It can vary a lot based on the usage patterns of the system. A lot of companies will use our products and get the data file, and they'll actually look at what the load consumed over several months to get a bit of a profile, to see what they can expect as sort of a pilot project before they actually deploy the projects in mass. So this is just a quick diagram of an example. You can see here, this is a quick example of some watt hours calculated over time. You can see that in a 24-hour period, you've got some usage here at 2 and 4 and in the evening, but not too out of the ordinary. But what you sometimes miss, especially with data loggers that don't read too often, is you might miss the peak power draw. And this would be an example of those those valve actuators that I talk about. They might only run a couple times a day, but when they do, they consume a lot of power for a very short time. But that peak is something you've got to take into account in your system sizing. So if you actually were to measure a peak power, you'd see pretty big spikes that wouldn't show up on only but the most granular of data logging. So you've got to take that into account. And we've supported a lot of customers with load profiling because it's almost always an eye-opening experience. And we've also talked to a lot of customers that have sold, as a system design standpoint, sold a system only to find later that their customer wasn't exactly truthful with them when they told them what it was going to actually run, and the load didn't behave in the way they expected. And guess what? The system may not perform as designed. Okay, a quick example here of what I thought is a really interesting system is an exceptional one that I wanted to mention is I think the picture speaks volumes here. You've got a very hard to reach site up in the far northern regions of Europe, and you've got solar as well as wind. And this is an older photo. I haven't seen any vertical axis wind turbines in some time, but this makes a really good point, is that on the winter side, you're probably wondering, how is this thing going to get any power? It's glazed over like some kind of dessert, completely coated with ice on all sides. And what was really interesting about this is I'd say that you're going to have a load disconnect almost certainly within a matter of days. But what this system actually did was they implemented a dual battery bank system where they used isolating diodes and some relays, and they put in a very large high capacity primary cell meaning the non-rechargeable type, that would actually keep the system running during these times and sort of get it through this hibernation process. And I took a quick example. Again, this is not a design diagram, but they were able to actually transfer between the rechargeable cycling lead acid design, or maybe it was NiCad in this case, and a standby battery that could be used to get the very low current draw through the winter. And I've never really seen a system like this, so I like to reference it often in presentations. I don't know if you've ever looked at a battery chemistry called zinc air, but if you're familiar with traffic equipment, we're of course very close to the New Jersey border where our office at Morningstar is located, and we're very familiar with, unfortunately, the orange construction barrels that all have blinking LED lights on them. And those will run for months, and they use a very low current draw, very long life zinc air battery that's common in industrial applications, but it is not rechargeable. So anyway, so moving on to load monitoring, this is another big aspect. A lot of Morningstar's products enable data capabilities on almost all of them that we address the industrial market needs with. Our EMC1 is a Ethernet converter that gives you IP-based connectivity, which is really the standard of choice for remote access of a variety of equipment and cellular networks and other networking and communication systems. You get you can add this to any existing products using the RJ11 interface, and you convert it from a programming device into one that you can access remotely anywhere on the internet. So you get remote control capabilities, you can retrieve the stored data logging files, you can do your own real-time logging, and you can even set up notifications to inform you of pending system problems before they lead to system failure. And the two major protocols that we support are SNMP, which is Simple Network Management Protocol. Anyone in the IT or communications or telecom space, that's really their go-to for managing the network. And now you can use it to manage the controller as well, all in the same system. And we also support Modbus, which on the automation and control side of things is a top protocol defined by SunSpec and the renewable energy industry, all kinds of automation in oil, gas. The smart oil field is driving towards IP-based Modbus connectivity for monitoring wellheads and other equipment. And we've got them both in one package, and I highly recommend. I want to quote a customer. I think they said, pretty much half of all system quotes monitoring is part of the discussion. So here's a really well-formed system diagram that shows a lot of the communications. You've got your storage, the ProStar PPT handling everything for a variety of applications. You've got the EMC1 providing IP-based connectivity through a router to the internet. And then you have the capability of monitoring a graphical web page with HTTP. You can get Modbus data if you're in the SCADA camp. If you're in the telecom camp, you can go SNMP and use your network management system to actually get that data natively right into your existing tools. So there's really a lot of options. Just a little bit of a diagram here. It kind of explains the difference between when you would use monitoring software for SNMP, when you could use our LiveView web GUI, which is a lot easier to use, but not nearly as scalable as SNMP. And then lastly, our MSView utility uses Modbus, and that's sort of a utility that is of our own design that gives you the best capability for loading presets, for loading configuration files, pulling data log files out, and even using some remote control applications. So, okay, so just a little bit of coverage there. You get all of your downloading of data logging capabilities. I would say paired with the right network management system, of which there are a lot of really good quality enterprise grade NMSs that are managing potentially thousands of devices across a very large array, that they're going to give you the best overall functionality, and also are really the most helpful at, I would say, sending notifications, because they're constantly pulling the equipment. They can send you an SMS or an email or other types of indicators that the problem is that there is a problem in the system and things aren't going according to plan. Okay, so when you do add the EMC1 adapter to products and get that IP connectivity, this is a little bit of the technical details regarding SNMP or Modbus. It's available via different protocols on the internet, so you can get that across any internet connection. Typically wireless is common, even satellite is not a problem. And this product uses version 2C of SNMP, which is pretty much the most commonly used version. And it's a really handy tool. If you look at some of Morningstar's other presentations, you'll see a much deeper dive into SNMP. So if you are in those industries and you want to really find out all the specifics of that, I would invite you to check out one of those webinars, of which we'll be having more in the future. Okay. And lastly, if you use Morningstar's load monitoring using MSView, that's another way to get very detailed data yourself if you're just connecting to a couple controllers. But I wanted to use this as an example because there's some really nice graphs there that show 3 days of operation. You can see what the solar array is doing, what the battery's doing. You can see what the load is drawing. And because load monitoring, it's not just about being notified that my battery's dead, because I'll tell you what, if your battery goes dead, you're probably going to find out other ways that your system's not running before the monitoring. The goal is, what can you do with the monitoring and the data ahead of time to look for the right behavior and the right trends to make sure that things are performing as they should be based on the design and they're not trending downward. They're not going in the wrong direction. So you can get detailed PV and load data. You can look at what's coming into the battery, what's going out. You can look at those various ratios. The array to load ratio can be used as a guidance to make sure that the system is designed correctly. And of course, you can graph all this data as well. So some other questions that could be asked are, what is the load consuming? Is it what we expected? Did our load profile reveal the true nature of this load? Or were we seeing some surprising effects? Are we seeing outages? Is the system going into LVD? It's not always a dead battery. We had some systems where we and our controllers actually monitor fault and alarm flags are logged in the controller's data logging file. So if we see a strange short circuit that's occurring or a high voltage disconnect that's being caused by another device in the system, it's not anything we have control over. There's a nuisance being created because of some products that aren't compatible with each other. You can see that in the data log file. And is the system able to recover from its depleted state? In other words, if you see that your battery is no longer going into absorption, but it's staying in bulk every single day, that's going to cause long-term sulfation and battery damage. If you find that you're getting closer and closer, ever so fragilely towards a pending LVD, and winter is on its way in 2 months, it's probably just a matter of time before you see sustained low voltage disconnect. And if that happens, take action now when you can reach the site easily, when you don't have to drive an ATV through the snow. Take care of that, because the data is giving you an indicator of what's to come. And lastly, are these heavy loads causing battery sag? I worked very closely with the support team in analyzing some problematic data, one of the many mysteries we attempt to solve for customers on a regular basis, and they were seeing that the battery was dipping. In other words, it was bouncing. It was sagging very low on load, and it was bouncing very high very quickly under charge. That's usually indicative of a battery that's just very old and reaching the end of its life. It's just not very robust. And when it starts to swing around like that, it's probably headed towards a failure. And you can see this by looking at the data. It's very helpful. So moving on, this is just a quick overview. I wanted to give a shot here of an indicator of what the features are that our products have. This is kind of our core product line, and I actually paired the TriStars together. If you're doing really large systems, mainly DC ones, you'll see the TriStar MPPT and the PWM are used as a combo. Sometimes multiple TriStar PPTs. I've seen as many as 15 in a single system for very large telecom applications. And of course, TriStar PWMs in load control mode to offer, the second functionality that I've been talking about. ProStar PPT, PWM, and SunSaver, they're 2-in-1 designs. Everything is built in. And all of the products on this page support the EMC1, which is our data gateway, as I discussed, for IP-based Modbus or SNMP protocol. So there's some of the ratings, and they're going to give you programmable load settings. They support the relay driver, so you can implement some of those relay driver functions that we talked about. We've got data connectivity, and of course, internal data logging as well that resides in the controller in a non-volatile fashion so that you can retrieve it. We've had to do, unfortunately, a few post-mortems by opening up the black box and seeing what exactly happened after the fact, but it's often very useful for the customer. So to bring it all together, here's an example of sort of everything I've been talking about in one. You've got remote data connectivity provided through an internet connection to the site, excuse me, where you're able to actually provide monitoring with SNMP or Modbus. We've got 2 EMC1s providing gateway connectivity for TriStar, PWM, and PPT products on the respective charging and load sides. We've got a battery in place. We've got a heavy DC to DC converter and a substantial load. You could drive that through the load controller. You could drive it through a relay. And one of the things you can do to take action is, in a lot of these systems, you'll often find a genset, DC or AC, depending on the configuration, provided as an auxiliary charge source. So in these systems, LVD is not an option. Before you have an LVD, you turn the generator on to consume some fuel. And a lot of these sites, diesel, maybe even propane for longer life, they can keep that LVD from ever occurring. And I often refer to this as active load management. Someone actually connecting to a site, seeing what's happening, monitoring this, disconnecting non-primary loads to save power, starting a generator, staving off an LVD situation. And let's not forget that one of the other really useful ways of managing your loads is to not only see the power it's drawing, but be able to turn it on and off. And you know what they say, 90% of the world's problems can be turned by turning something off and turning it back on again. I think it's the go-to answer for any IT support. And that happens a lot in these systems. And you can remote into the controller, you can cycle the power, you can bring that load back up again, you can connect to it to another device at the site to see what's going on for troubleshooting. So this gives you a lot of options at these sites because, you know, renting a helicopter is not what you want to do if you can connect to the site remotely from the comfort of your office. And we enable that with a lot of these products. So that is the end of my presentation. So I just want to make a quick pitch. I'll start looking at some questions here. Stay tuned. We are going to be doing a little more detail on a system sizing best practices. That's sort of it is not a start to finish design tool for, you know, heavy industrial engineers. It is more of a best practices, kind of get your feet wet sort of discussion regarding how a system is sized and in a lot more detail about some of the things I touched on in this presentation. So that'll be scheduled soon. So keep an eye on your email and newsletters from Morningstar Corporation for updates on that. And I will now refer to some questions. Okay, one moment. Okay, so one of the questions is, one moment here. Give me 1 second just to expand. We've got a very active crowd here, which is a great thing. Let's see here. Okay, one of the discussions is how to access the system remotely using MSView. MSView is actually designed to run on the latest version of Windows, including Windows 10, that can run and easily provide access to a system anywhere on the internet. It's not designed to scale, but it is compatible. If you don't have a Windows machine, you can use any web browser. This could be Safari, could be Edge, Chrome, a mobile device, tablet, phone, and you can also connect to the HTTP connection and see a graphical web display of the system using a simple web browser. And you'll find in our coming products, a lot of the web designs really are where we're headed from a design standpoint across the product line, because it's just so hardware agnostic and easy to manage, and there requires no installation of software. So, okay, let's see. One other second. I got a question regarding being able to charge the battery fully at least every 2 weeks. Yeah, that was sort of what I was referring to, is you definitely want to make sure that you are getting the battery into at least an absorption, if not a complete absorption, and ideally float, although that hardly ever occurs where you have that much extra power, but you want to get through a solid absorption period at least every 2 weeks. If you're not doing that, if you're seeing the battery sit in bulk repeatedly over many days, then you're just not getting enough energy back into the battery. And that's the thing I was trying to refer to stay away from if you are doing a system sizing. Okay. Let's see, a couple other things here. For telecommunications, do you currently have them in the field working with wind energy simultaneously? Yeah, we do have some systems working with wind energy. We do not have a heavy focus on managing the wind ourselves with the power electronics side, but a lot of what we do with the application support, and Doug Grubbs, who is our senior application support staff member who's actually on this helping me with the presentation, does deal with a lot of wind systems and can provide a lot of information on integrating wind turbines along with the solar controller so that they work well together, and that you can actually, utilize them to provide wind when you've got it and solar when you've got that, and that they don't fight each other. So integrating those together is really important. And wind is nice because you get power almost 24/7 if there's wind resource available, and solar often complements that when there's not wind. Let's see, a couple other questions here. Which of Morningstar's controllers can do both charge control and load control at the same time? If you look at, I'll tell you the ones that don't. The TriStar MPPT is a charge controller only. and it is designed only to provide charge control. If you need to add load control, you have to use a TriStar PWM together with it, okay? But most of our product lines, the SunSaver MPPT, the Sunlight, the ProStar PWM, and the ProStar MPPT, all are combination products that have charge control and load control combined into the same product. You don't have to use it if you don't wish to, if you're running an inverter or other device that you want to run off the battery, but you can do that if you desire. And that's when you get the most visibility of the system. That by far makes up the vast majority of the volume of our industrial off-grid autonomous systems, is those combination products, SunSavers and ProStar families. Okay, let's see. Quick comment, I guess my quote, batteries don't die, they're actually murdered. So you're right, that's often true. They don't die a natural death. It's actually a homicide, actually. So that's a really good comment. I like that, thanks. Can you charge lithium iron phosphate batteries? Yes. Morningstar has a pretty sophisticated program in place called our Energy Storage Partners Program. You can find that on the website, and that is also managed by both a combination of the marketing team as well as our applications team. And the ESP program provides specific battery set points that can be loaded in just the way I spoke about to provide you manufacturer approved, agreed upon charge settings for a variety, if not the majority of the leading lithium ion or lithium iron phosphate batteries that are in the industry. You can search those. There's well over I'd say one to maybe closer to 2 dozen maybe of battery partners that are involved with that. And you can find that on our website, including the downloadable preset files for each of our products for those batteries. So definitely reach out to us if we can help, because we want to, lead acid is a strong part of the industry still, but we want to help pave the way towards reliable and basically give you lithium iron confidence in those batteries by giving you that assistance. So those are capable. I'd say pretty much most of our products can support that if they support custom programming. A few other questions here. I'm going to stay within an hour, but if you guys want to hang on, I'll answer a few other good ones here. A question is, do you support SNMP 3? So version 3 of SNMP actually enables encryption on top of that. That is not something we provide support for right now. It requires a much more capable gateway. We found that most of the customers using SNMP currently were satisfied with 2C because they provide their own transport level encryption for their connectivity themselves. Okay, so that's what we have right now is version 2C. We're definitely looking at version 3 for its encryption capabilities, as well as other protocols that could be supported in the future, such as HTTP for representational state transfer of data. That's another common protocol. MQTT, also encrypted protocols. So we're definitely trying to get more advanced there if we can. Let's see here. A few of you, if you had any issues with connectivity, I know the internet is under great stress as we're all working from home, but definitely make sure you check out the fact that we've got the PowerPoint presentation available. And I'll remind you again, this webinar is being recorded and can be available on YouTube in a very short amount of time. Oh, lastly, if I can interrupt the questions, one very important thing is that for all of you who attended this, thank you very much. And you will actually receive one NABCEP continuing education credit for participating in this webinar. So if you are a certified NABCEP installer, great group of people, by the way, looking forward to getting back to that show very soon, and you wish to get your continuing education credits, we can provide that for you. So thanks for participating, and we hope that aids your pursuit in the industry. Let's see. As for the custom settings of the TriStar MPPT 60, does Morningstar offer assistance in creating a custom file? If you look on our website, we do have our MS View software, and there's a very capable file for assistance, as well as some technical documents. We can follow up with you after the fact and maybe provide some guidance on that to explain what the settings are and what they do, such as the ones I talked about, so that you can get the right preset. A lot of our distributing partners are also well versed in our controllers, and depending on your application, they can provide a custom set point based on the battery of your choice that can be programmed into the controller. So definitely something that we can assist with. There is also, for those of you that had more interest in our relay driver, there is a relay driver specific webinar. Everything you want to know about the relay driver takes it even further than load control. And that webinar is available on our YouTube page. And we're trying to do more of these deep dives into our products for people that are looking for, specific details and something really more interesting. And the relay driver is presented in detail about all the options that can enable, because it's a very capable tool. I like to refer to it as the Swiss Army knife of our product line, because it solves a lot of problems, does a lot of really cool things in the system. You will receive an email, just a quick note also from my partner staff here, Mark. If anyone needs a recording very quickly, tomorrow you'll be receiving an automatic email also from GoToWebinar, where you can review it even sooner than we can get it on the website on YouTube. Okay, let's see. Yes, a quick comment on to further follow up on the SNMP version 3. When you do have IP-based connectivity, make sure that you take into account proper network security. We do have a feature on our product that you can enable that switches off remote firmware or preset writes. In other words, it turns the controller into a read-only mode so that you can get it on the internet and you can physically disable any ability to change the settings. So you can't, it's read-only, and we enable that on our products as a security measure. We definitely recommend proper network security. We're not system specialists in terms of networks and switches and routers and firewalls and IP-based security, but we do have that feature on there, and it will turn the controller into a read-only product to provide an additional layer of security. Let's see. Just a quick comment on, I will take just 2 more quick questions, and then I'm going to finish right on the hour, if that's okay with you. I'm getting some really interesting ones. Let's see here. Okay, so one comment about multiple DC to DC converters. These are the trials and tribulations of a variety of loads in an off-grid system. And the TriStar 45, in some cases for a customer, is very sensitive to outrush current. And in this case, they were asking about the ability to disable an LVD to get around that. So let me speak to that really quick. So if you have a controller that has load control, you can bypass the LVD and go directly to the battery. That won't hurt the design. It won't affect charging. You lose current measurement, and then you're not susceptible to this inrush current. But I think I will follow up with you on this, because there has been a talk about being able to actually disable the low voltage disconnect while still retaining current control on the product. That's something that has been given to us as feedback before, so we would like to follow up. That is from Glenn. And Glenn, I'll reach out to you and we'll get more details on that, because you're right, that is a system where you want to monitor current, but LVD is too susceptible to the inrush currents from these DC to DC converters, and you want to basically disable that function. We have to be careful, because we can't sometimes disable short circuit protection. Sometimes overcurrent protection and short circuit protection are essentially one and the same, and there's often a way that we can't disable that because the controller would be susceptible to damage and far worse items. So that's something we'll have to talk about in more detail. Okay, I'm going to take one more quick question, and then I'm going to sign off. And what we will do is we're going to look at all these questions, which are recorded into the GoToWebinar system, and we love to follow up on as many of them, if not all of them, after the fact when we have a little more time. And because these are all great comments, and that's the point of having trainings of this nature, so that we can hear from you guys and react and support you. Let's see. One second. We do not have a recommended way to alter. Let's see. Do you have a recommendation on how to increase the PV array size according to the number of days of autonomy? System sizing will be covered in a future webinar. That is a perfect conversation to have during that presentation, more than I can get into here, but we are going to specifically focus on that aspect of system design, talk about days of autonomy, load to loss probability, array to load ratios, where you should be, and what are the best practices. So we will cover that. I did want to also give a quick shout about another future webinar that will be coming soon, and that is also on our string sizer. It is not a sizing tool for battery system sizing and capacity for off-grid, but what it will do is provide you with detailed string sizing and voltage analysis for each of our MPPT charge controllers based on tens of thousands of modules from an industry database that we subscribe to and that we modify. Doug, our applications engineer, is also the guru when it comes to that tool, and he has all of that set up. And I think we're going through another recent update of new modules, and the string sizer will help you configure proper input voltage windows, battery array configurations, overcurrent, oversizing of the array, and all those types of questions that you may have. And the string sizer can be found on our website, and it's constantly being improved and is a very helpful tool. So definitely check it out, and that will be another topic for a future webinar. You're going to see quite a bit of activity online with Morningstar during this interesting time of home captivity. So we'll keep trying to provide you guys lots of weekly content as often as we can. Okay, I think I want to stay on time, so if I didn't get to your question, I apologize. Thanks for participating. Thank you to NABCEP for partnering on us so we can provide continuing education credits and make these of more value to you. Keep an update on our coming webinars, and stay tuned for the presentation. Again, I'm Brad Burwald, Product Manager, and thanks very much for attending. Okay, have a great day. Stay safe, and hope to see all of you back in your offices watching our webinars very soon when we get past this challenging time in society. Okay, take care. Thank you very much.